so that you can easily understand. So it has a key residues in the binding interface for the integrase and LEDGF. These are the key residues at the interface. We try to use this information to identify user structure-based drug discovery. I'll tell you how we use this information for structure-based virtual screening. So fortunately, we have a crystal structure, which is with the HIV1 integrase and then the human LEDGF. So we have seen the key contacts at the interface. What we do is that there are many contacts. We need to identify what are the key contacts so that we can use that key contacts information for identifying drug molecules. So what we have done is that we try to develop mutates, means alanine scanning mutagenesis, means mutating the one each residue into one single mutants and double mutants. So you can't mutate everything at a time. So then it lost the protein function. So what we do, we try to do single mutants and double mutants and validate which are the critical residues, which are the hotspot residues, so that we can use those hotspot residues for virtual screening. Using those information, we have identified one of the critical two hotspots was a 168, which is a residue 168, and 170, which is a glutamine and glutamic acid, aspartic acid and glutamic acid, which I use this. You can see the very unstable in this system. Then what we do, we use that information, and then we go for with different databases, as Cambridge databases and other databases. We use that databases, and then we try to screen molecules, some thousands of molecules, using those hotspots, which you identify from the mutagenesis. So that we have used virtual screening studies, and we identified is a new novel molecules. This is one of the hot area, which is viral host protein-protein interactions, which I'm doing right now. So even I'm trying to develop this landscape for using AI and machine learning. I'm trying to do for all HIV-1 viral protein interactions. Sorry, HIV and human protein-protein interactions. So yeah, it shows using our mutagenesis, we identified two key residues. So it really binds to the 170 and 168, especially this key residue of 170, our ligand binds. So that shows using this integrated approach, using mutational studies, MD simulations, and structure-based virtual screening, and MMGPSA binding free energy, we identified molecule that can block these protein-protein interactions. So it may not be very successful for all protein-protein interactions, but in this case, this is very one of the good studies. We collaborate with the experimental studies, and they are doing this, continuing these studies further. So these computational methods we have used and the hits identified in this study, which provides excellent guide to disrupt these HIV-1 integrase and human LEDGF protein-protein interaction. So this is why we have published the work blocking this interaction. Now we are trying to collaborate with experimental scientists. And then I want to thank Bowie State University providing nice facilities, and the BSc students and the pharma advisors. I collaborated with I've done my PhD in postdoctoral studies. We are located right. I mean, if you see the outer loop of Washington DC, it's just maybe 20 miles from Washington DC, which is a hot area. Which is we are rightly located into the areas where NIH institutes. There were 23 NIH institutes who are there within 50 miles of Bowie State University. Can you imagine? So I try to collaborate with many, and now I recently joined past 6 months of trying to collaborate with for experimental studies on this. So yeah, we are located in the prime location. So I'm trying to establish my lab. So